talk to you about functional reactive programming in Swift, which is pretty cool. We at Artsy developed an application recently that used Swift and functional reactive programming with the Reactive Cocoa library, and we learned a lot of lessons from that, which we'll get to in a little bit. But for now, let's go over what we're going to talk about. So first thing, we're going to give a brief description of what functional reactive programming is. Then we're going to move on to Reactive Cocoa, which is a Cocoa-based library for using functional reactive programming in Objective-C and Swift. And finally, we're going to talk about some lessons about how you can get started doing this today. So the big thing about functional reactive programming is a signal. Signals are super, super important, and they're a little different. They're a very abstract concept. They send values over time. If anyone's done signal processing from an electrical engineering perspective, this is probably familiar to you. It's basically like a pipe that sends values through it, and it just keeps on sending values. It has no concept of what is currently being sent. It doesn't have a concept of what has been sent in the past. It can only send new things. And eventually, a signal completes. It stops sending values, and no more values can be sent. Alternatively, the signal can produce an error, after which no more values are sent either. So basically just a pipe. The really interesting thing is, just like pipes, signals can be chained together in sort of a plumbing inside of your application code. In math terms, it's basically taking a function of another function, which is really, really cool, I think. So that's like the briefest intro to functional reactive programming I could do. Now we're going to talk about Reactive Cocoa, and we're going to get into some actual code and less abstract. I'm not going to wave my hand around as much to explain concepts. So Reactive Cocoa is this framework developed by these incredibly smart engineers at GitHub. They're really great. They use it themselves, so you know that it's going to be. It's not going to disappear next week. If you've used other application frameworks before, like, oh goodness, 320 comes to mind as something that, just kind of fell away, or ASI, HTTP networking, whatever it was called. Reactive Cocoa is not really going anywhere. Currently it's being worked on for full Swift compatibility with a whole new API. Everything I'm going to talk about here is the existing Objective-C API using Swift to access it. So signals typically are built on key value observation. This is a technology that iOS developers should be pretty familiar with. Key value observation means that you can observe a model or an object, any object, and say, whenever this property on this object changes, send me a notification. Pretty simple. You can also create a signal manually, but most of the time we're using KVO. So instead of setting up a callback block to say, basically, when this value changes, execute this code, I can create a signal out of that. So when the value changes, the signal sends a new value. And then we can do things with that. So what can we do? Well, you can subscribe to a signal in order to produce some side effects. So if something changes and you want to execute some code, you can do that, just like KVO. But you can also use bindings, which we'll get into in a little bit. And bindings are really important. So this is code that you don't need to remember because it's on GitHub. So you can go to my GitHub profile. These slides will be online as well. Basically, the rack observe, it was a C macro in Objective-C, but Swift doesn't have a preprocessor yet. So we need to use a Swift function, which is defined there. And this is how we create a signal. We say, let some signal equal rack observe object number. This observes the number property of the object. And then we can say signal.subscribe next, do something. So whenever the number property changes on object, that block will get executed and will print a new value. This is the hello world of Reactive Cocoa. But that's pretty boring. I mean, you don't need me to come up here and tell you how to print things to the command or to the log when properties change. That's really boring. So instead, let's do something really neat. And this is signal operators. This is really cool. I love it. Basically, they are functions that operate on signals in order to return a new signal, which you can subscribe to. So graphically, this looks a little like this. We've got one signal coming into another signal, and then that signal is producing new values. So the signal on the left is sort of, it ends with the operator, and the operator produces a brand new signal. The really canonical example is map. It transforms values from one into another. So if you have a signal that sends numbers, you can turn them into strings of that number. For instance, it's really the canonical value transformation. And the code looks like this. We have our signal just like before, but we're mapping it to be from a number into a string. This is kind of boring. So something more interesting is this. If you have a person object, then you can say, I just want the person's name. And then you can map the person into a string that represents their name. This is a little better. In Swift, something you couldn't do in Objective-C with Reactive Cocoa is have a function to name, and then you can say signal.map to name, and it reads a lot nicer. You don't have this inline block definition of how to use or how to invoke this mapping. So that's really nice. Another signal transformation is filter. Filter it does exactly what it sounds like. You have a block, and every new value sent over the signal is sent to this block. If the block returns true, then the signal sends that value. If it returns false, then it doesn't. It filters out some values. Code looks like this. So we say we've got some number signal, we're going to filter it, we're going to return true if the object is greater than 5. And then the subscribe next block is only going to be executed for numbers greater than 5. Pretty simple. But here's the really cool part. Bindings. You can bind a property of one object to be a signal. So whenever the signal sends a new value, the value that you're bound to will be updated automatically. So say I have a signal that sends text values, and I have a label with a text property. Then every time the signal sends a new text value, the label's text property will be updated automatically, which is really cool. Bindings are one way. So in that example, changing the text property on the label would not change the text property on whatever you're observing. And bindings are super powerful. So again, this is a whole bunch of code that you do not need to remember. It's part of that same GitHub repository, so you can check that out online if you like. Basically, it just defines the sort of rack struct that we used to use C macro for in Objective-C, but we can't now. So this is how you create a binding. It's one line of code. And now whenever the some string property on self changes, then the text property on the text field will be automatically updated, which is really, really cool. So this kind of leads us to something that's also very fundamental to Reactive Cocoa, and that is derived state. Most applications out there, they need to have some sort of state. When you print something to the screen, when you accept user input, you are changing the state of the world. It's not a functional way. There is no functional way except these really weird things with the monads in order to accept user input or print something to a printer. Printing something to a printer is a side effect, and functional programming doesn't have side effects. So this is where I love functional reactive programming, is that it kind of, it lets you have side effects but still use functional paradigms. So we avoid state in Reactive Cocoa by deriving it instead. We say you can have a property, but bind that property to some signal instead of setting it manually. So yeah. There are some other operators that I didn't really have time to talk about. Combine latest is really useful for combining several signals into one signal, which is good if you need to choose between several different values, or if you need to wait for multiple conditions to be met. Take until is really great. It completes a signal once another signal sends a new value. So if you only want to bind a property of a table views text field, you can say it's equal to this signal until the cell is being reused. And then once the cell is being reused, the binding disappears. Schedule on is really good for shunting execution from one thread to another, which is really great. Throttle is really great if you have something that produces it's a signal that produces a lot of new values, and you only want to update the user interface once a second instead of thousands of times a second, which would just be a waste of CPU power. Throttle can be really great. And then there's not, and, and or, which are the logical operators that they behave exactly as you expect them to. So let's talk about getting started, because everything I've set up until now has been code on a screen, and it's kind of hard, especially this early in the morning. Well, it's early for me. I don't know if you guys are awake yet. But how do we get started? It's actually very easy. CocoaPods, which is I don't know if you can see my giant CocoaPod sticker on my laptop, but CocoaPods is my preferred way to deal with dependencies in code. Unfortunately, CocoaPods doesn't support Swift libraries yet. It's close, but it's not there. So you have to use Git submodules or subtrees, or your preferred way to import the code. And then switch to the Swift development branch, because if you use the master branch, then it won't work. It just won't compile. So that's how you add it to the project. There are a few sub-modules of Reactive Cocoa which you'll need to install, but there's a demo app that I've got up on GitHub that I'll show you the link for later. It's pretty easy to get set up. So yeah, once you have Reactive Cocoa installed, start by replacing any key value observation methods you have. You know, if you're responding to a changed property by executing some code, instead of having a KVO method, use a subscribe next around a signal instead. And then start looking for other opportunities to use signals instead of properties. And I get asked this a lot, like, what do you mean? Like, how do I determine if a property is a good candidate for turning into a signal? And I've got some instructions for you. First, whenever you're about to create a property, that is the perfect opportunity to decide whether or not it should be a property or a signal. If it's important to have the value of the property accessible after it's been set, then it should be a property. But if you only need the property value when it's being set, then a signal is fine. So a really good example is we had a switch view in our application. It's basically like a tab interface. You have multiple buttons. Tap one button, it gets selected. Tap another button, it gets selected instead. We didn't have a currently selected index property. We had a index changed signal, because after the value has been set, we don't care what it is anymore. The animation that changes the user interface is already completed. There are also things like, is the reason you're creating this property just so that you can have side effects when it changes? If that's the case, then why have the property at all? Why not just have a signal that can trigger side effects? So I've got a demo. It's up here on my GitHub page, github.com/ashfurrow/mdltdev. Really easy to find. I do have time, so I'm going to go over some actual code, which is going to be awesome because I love live coding. And I've got this super huge Xcode thing. Maybe that's too big. Let's go with presentation. Can everyone see this code? Yeah. Awesome, thank you. Whoever said that in the back. I don't even have Wi-Fi right now, so the network one's going to be a little bit tricky because, networking code doesn't work if you don't have access to the network. Oh no! Oh, I love Xcode 6. It's so great. It's so buggy. If anyone out there is an iOS developer, you know exactly how frustrating it's been over the past 4 months. So we've got Reactive Cocoa demo. Hit run. Source kit crashed. Who's surprised? I'm not surprised. Yeah, there we go. Okay, so build succeeded. Is it going to work in the simulator? Yes, it is. Okay. So I've got a table view, pretty simple. We've got 3 demos to do. The first is a gesture recognizer demo. This is really cool. You can't see most of the simulator right now. That's okay. You can see the top part, which is important. So I'm going to simulate a pan gesture on the screen, and you'll see that there's a box that follows my finger. And as I move left to right, let me scroll down a little bit so it's more obvious. As I move left to right, you'll see that the hue of the box's background color changes. And as I move up and down, the brightness changes to be really dark at the top and really bright at the bottom. And that's really cool. So, you know, how do we get that? I mean, this is not something that you would really use in the real world, a box that moves with your finger. But you can write code like this really easily. So let's take a look at what it looks like. Okay, so I create a gesture recognizer at line 18. Fairly straightforward, just create a new one, add it to my view. And then I create this binding on line 21. And I say, bind the box view's center property to be a mapped version of the gesture recognizer's gesture signal. So every time the gesture recognizer fires, the gesture signal sends a new value. And the value that it sends is the gesture recognizer itself. So we can map the gesture recognizer to be the location in our view. Once we have the location, we just bind it to the center property of the box, and the box follows our finger. So with basically 2 or 3 lines of code, we've got code that lets you move something around the screen just by dragging your finger. The color is a little bit more complicated. Again, it's a mapped version of the gesture signal, but we get the location in the view, and we calculate a hue based on where it is horizontally, and a brightness depending on where it is vertically, and return a new color instance that we bind to the background color property. And that's it. That is the whole code right here in the view code. So I've got one method in my view controller to dictate all of this behavior. That's pretty cool, I think. So let's look at another demo. I've got a login demo. How many people here have written an interface that looks anything like the following? Yeah, I expect all of you have. I have written it like 100 times, and I hate it. So it's basically an email address field, and I'm going to type an email address. Imagine if I had hash.com. That'd be an awesome domain name. Okay, so I've got a valid email address, but the password button is grayed out, as it should be, because I haven't entered in a password. So I'll enter in my password. Great, okay. And you'll notice that once I hit 6 characters, the go button became clickable. This is something that's really important. Validating user input fields is something that's really common. And on iOS, it kind of sucks. You have to register as the delegate for the text field property, and then remember which delegate method to implement, and then you have to switch based on which text field is sending you the, oh god, it sucks. So instead what we can do, is in the code. Okay, so I've got a valid email signal, and it says whenever you get new text, map that text to a Boolean, depending on whether or not there's an @ sign in the field. That's basically the only way to determine whether or not an email address is valid. Like there are regexes for it, but none of them work. And then that's our validity check for an email. And then we say valid password. Valid password, it's valid if it's over 6 characters. That's it. And then all we have to do is bind the enabled property of our button to be a combination of those 2 signals, which send Booleans, and we'll AND them together with the reactive cocoa method. And that's it. In this whole view controller, including that giant comment that Xcode adds for some reason, and all of our boilerplate, our view.load method is 15 lines long, and we've got form validation done forever. It's really cool. And the last example, I don't think will work because I'm not connected to the internet, but I anticipated this. So I have a button called Go, and when I click it, it's going to change my lovely image view to be filled with a picture that I took on vacation. So I hit Go, and it's not going to work because I'm not connected to the internet, and it should come up with an error once the network connection times out, which I don't think it will, because it's going to take like 60 seconds. So anyway, I'll show you the code for it. It's probably the most complicated code in the demonstration. I've got the URL to access, and then I'm going to bind the image view's image property to be the Go button's signal for the control event touch up inside. So when you get that control event, the signal fires. Then I'm going to say take 1, so I only want to do this once. And then when it happens, I want to print something, say start download, to the console, and then start the little spinner beside the clock to let the user know that network activity is occurring. Once that finishes, I've got this then block here. This is a block that returns a new signal to be subscribed to. And I'm going to say create a request with that URL, create a network signal that's based on a category method on NSURL connection, send the request asynchronously, deliver it on the main thread scheduler, and you're done. And then we have this map to image, so I'm going to take whatever the network signal sends, and I'm going to turn it into a UI image, and print the downloaded complete. If anything happens and an error is thrown on a signal, instead, I'll print the fact that an error occurred, and then I'll return a new signal, and all this new signal does is return an error image. And then once that finishes, then I want to say the network activity indicator is not visible. So let's go back to the simulator and see what happened. Nothing happened. Okay, right. That's very strange. Start download, downloaded. That's strange. Go. It thinks it downloaded, but it didn't. So there's probably an error in my code. If someone wants to send a pull request, I'll accept it. Yeah, so that's a very brief demo. There's a couple of key points to add. Use subscribe next for side effects. Use do next for side effects where you want to allow values to pass through. Network results are by default delivered on a background queue. So if you're doing user update or user interface updating, make sure to deliver on the main thread scheduler instead, because otherwise UIKit will behave strangely. If you want more, the company I work for, Artsy, we developed it's an application for iPads that we install on our iPads and then use at art auctions, so people can bid for artworks, swipe their credit card, the whole 9 yards, and it's completely open source. It's been open source since day one. It's available on GitHub at this address. And if you have any questions about it, just file an issue or tweet at me, and I'm more than happy to explain any part of that code. There's lots of examples of things that you can use Reactive Cocoa for. So observing model properties, that's really a basic example, lots of that. User interface changes depending on signals, lots of that. Networking code. We actually wrote an entire library around Reactive Cocoa and networking using AlamoFire for this project, and that's open source as well. So this is still a work in progress. We hit 1.0, but we've got lots of feature requests from our designers and things we couldn't get to for the initial deadline. So be aware of that. Be prepared to answer questions that your teammates have, because this is very different. This is a different way of programming than imperative style. But there is a community to support you. If you send me a Stack Overflow question or a GitHub issue, I'm more than happy to look at it. The creators of Reactive Cocoa are very happy to look at it and help you, so don't feel like you're alone. To wrap it up, functional reactive programming uses signals instead of state. Reactive Cocoa uses those signals to avoid state, and getting started is actually really easy. If you have any other burning desires to learn about Reactive Cocoa, I've got a book published on LeanPub about this, and you can go check it out at this URL. It still uses Objective-C, but all the same concepts that we talked about here still apply. Thank you very much.
Thank you. Thank you for this crazy technical stuff. Very interesting. I have a question for you. So imagine a situation like you were hired as a developer to build a mobile application from scratch. What would you use? Swift or Objective-C and why?
That's a good question. If I was hired to do it and I was a contractor, I would definitely use Objective-C. With the project at Artsy, I had to say that I could use Swift if I wanted to, and there were several times that I regretted that decision because the tools aren't ready in Swift, and I hope they will be soon, but I would stick to Objective-C for now.
Okay, got it. Thank you. Ребята, есть вопросы?
Thank you for the talk, Ash. I found Reactive Cocoa to be a bit hard in debugging when I tried it recently. Do you have any improvements in this area in Swift at all with Swift?
The question was about debugging. Yeah, that's a really common problem that people have when they switch to Reactive Cocoa. You're not the first person to experience difficulty when you're debugging. The best advice I can give, and I gave this to my colleague who had the same problem, is just to avoid or ignore the Reactive Cocoa's methods in your stack trace. They are implementation details. Just pretend like they're a grayed out UI kit, and then just look for your app symbol. And you can even filter it in the debugging pane in Xcode. You can type in like a string at the bottom, and it filters by that string. So just type in your app name, and that helps. So yeah, it's just something you get used to with experience. Unfortunately, there's no way to say like do this and it will be easy. And I'm not aware of anything beyond like they want to make the library simpler to use with 3.0. That's the big driving force, is to make it simpler. Beyond that, I don't think there's any specific plan to address debugging.
Ребят, можно еще один вопрос задать?
Hi, thank you for the great speech. How do you think, does it work good with code reuse? As I can see, you can, if you start to use Reactive Cocoa for some component or some code that you want to reuse, you should use Reactive Cocoa later to use this. How does it work? Do you need some adapters or something like that to integrate without Reactive Cocoa?
You can certainly have a layer that just uses Reactive Cocoa, and everything above that layer does not. That is totally possible. And the way you do that is just binding properties to signals. And anyone using that class isn't aware that it's being bound to. All it sees is a read-only property. But the class itself can write to it, and then you have your abstraction that it's not using Reactive Cocoa. I personally use Reactive Cocoa all over application code. They have a lot of category methods on UIKit and Foundation classes that make using Reactive Cocoa a breeze, just very easy to do, no matter where you are in the application stack. So there's also an approach called model view model, which the Windows Phone developer could probably tell you more about. There's also it came from Microsoft, that's why I say that. There's also an article I wrote on Objc.io talking about MVVM in the context of iOS development. And I find that using view models is a really great way to encourage code reuse and avoid duplicated code. Okay.
Thank you, Ashley.
Thank you very much.